Hi, this is the Unit 5 Lesson 3 video. We're going to be solving quadratic equations with the factoring method. So remember, a quadratic equation is one that has x squared in it, and for a couple of classes we've been solving them using the square root method. So now we're going to switch methods and learn the factoring method. As a quick reminder, the methods of factoring that we know from the previous unit are GCF, dots, easy trinomial, and tricky trinomial. Okay, quick reminder here about each of those methods, just so we have this in our heads. When we factor by GCF, the GCF will be a monomial, and the other factor will be a polynomial. So you have the monomial times the polynomial. When you factor by dots, you use the square root method, where you take the square roots, and you have two binomials, one with a plus and one with a minus. When you factor your trinomial, you do the AM, and then the answer will be two binomials. And when you factor a tricky trinomial, you do the arc and the AM, and again your answer should contain two binomials. So it's a very quick reminder. Okay, so one other thing to think about. If I told you I'm thinking of two numbers that multiply to 0, would you be able to say that one of them has to be 0, right? So if I have two numbers that multiply to 0, one of them has to be 0. So if I tell you that 2x is equal to 0, then x has to equal 0, because, I'm actually going to do this real quick. Because if I say that 2 times the number is 0, then that number has to be 0, since this number is 2. If I tell you that a times b has to be 0, then either a has to be 0 or b has to be 0, or both, in order for them to multiply to 0. So either a is 0 and then b can be anything, or b is 0 and a can be anything, and in either situation we'll end up with an answer of 0. So here's the last tricky part. If I gave you two binomials that had to multiply to 0, then one of the binomials would have to equal 0. Okay, so if I gave you two binomials that have to multiply to 0, like x plus 2 and x minus 1, then either x plus 2 has to equal 0 or x minus 1 has to equal 0. Okay, so if two things multiply to 0, then one of them has to equal 0. What's cool about that, this is the same thing I just showed you, what's cool about this is that then we are able to solve for x, because if I say x plus 2 could be 0, then I can solve for x. Minus 2, x equals negative 2. And if I told you that x minus 1 could equal 0, then I can solve for x here. Plus 1, x equals 1, which means that either x has to equal negative 2 or x has to equal 1. Now if I take this original equation all the way up top here and I plugged in negative 2, what's negative 2 plus 2? It's 0. And if I plugged in 1, what's 1 minus 1? And that's 0. So as long as one of those two things is true, then they will multiply to 0. Now, why am I talking about this? Because this is the exact concept that helps us solve quadratics when we're using the factoring method. So if a quadratic is equal to 0, so this was the important thing that we were just talking about, it has to be equal to 0 and factorable, then you're going to actually factor it and then set each factor equal to 0 and solve for x. And that's the method we're going to be using. This is the factoring method. You're going to make sure it's equal to 0. Okay, so that's always going to be the first thing we're going to do. We're going to factor it. That's going to be the second thing we're going to do. And then we're going to set each factor equal to 0 and solve for x. And that'll be the third thing to do. Let's jump into some examples. X squared minus 5x minus 50 equals 0. So step 1 is that it has to be equal to 0, and it is, so we're good there. Step 2 is to factor the quadratic. So you have to decide which method of factoring to use here. So this is where your knowledge from the last unit will come in handy. X squared minus 5x minus 50 is a trinomial. So I need two numbers that add to negative 5 and multiply to negative 50. And if you need to, make your list of numbers that multiply to negative 50, like 1 and negative 50, or negative 1 and positive 50, and so on and so forth. You can have 2 and negative 25 and switch them, okay, and keep going like that. But this video is not about how to factor. You should already know how to factor. So after you make your list and figure out your factors, remember you're going to make your two sets of parentheses here. X squared is equal to x times x, so we split that up. And then the numbers that add to negative 5 and multiply to negative 50 are negative 10 and positive 5. Now, you're used to seeing this from factoring. Now this equals 0 has to come down with the answer. So now we know that x minus 10 times x plus 5 has to equal 0, which means that one of these two factors has to be equal to 0. So here's how we're going to figure out what x has to be. We're going to come down here and we're going to split up the two factors and make what I call a t-chart, because what I just drew in blue there kind of looks like a T. In your t-chart, you're going to set each factor equal to 0. So on this side, I have x minus 10 equal to 0. And on this side of the t-chart, I have x plus 5 equal to 0. Okay, so this factor equal to 0 and this factor equal to 0. Now we solve for x on each side. So over here, if I add 10 to both sides, then x is equal to 10. And if I subtract 5 from each side, then x is equal to negative 5. So I have two solutions because a quadratic equation usually has two solutions, and the solutions are 10 or negative 5. And one way to show your answer, as we've been talking about, is to put those two numbers in squiggly brackets. And that's the most common thing you're going to see with the factoring method, is the squiggly brackets like that. Okay, so 10 or negative 5. If I were to come back up here and plug in 10, I would get 0. And if I plugged in negative 5, I would also get 0. And you can check that in a calculator if you want. Here's another example. Once the equation is equal to 0, we figure out if it's factorable. Okay, now, side note, this can be solved using the square root method like we did in class before, but it can also be solved using the factoring method because this is a dots problem. So if I come up here and think about dots, dots has two sets of parentheses, one with a plus, one with a minus. The square root of x squared is x, so I put it twice. The square root of 81 is 9. So I put that twice, and remember the only difference here is that now this is equal to 0. So now we can solve for x by making a t-chart. So your t-chart goes here. Right where the two factors are being multiplied is where your t-chart goes. So right between those two parentheses, and I could make a straighter line, sorry about that. And so I make what looks like a t, and over here I say, okay, x plus 9 has to equal 0. And so if I subtract 9 on both sides, then x has to equal negative 9. On this side, x minus 9 has to equal 0. And if I add 9 to both sides, then x has to equal positive 9. And so my answers, my two answers are negative 9 and positive 9 in squiggly brackets. All right, another example. So again, this one is already equal to 0. Don't worry, you'll see lots of examples in class where it's not equal to 0, but for now we see one that's equal to 0. And we need to decide if this is factorable. It's kind of tricky for this one to tell if it's factorable because it's a tricky trinomial. There's not a GCF, so it's a tricky trinomial, so we're going to have to just go ahead and jump in and check it. So tricky trinomial means we multiply over the top, so 2 times negative 10 gives us negative 20. So we want two numbers that multiply to negative 20 and add to negative 9. Remember the a number is still in the middle here, okay? And so if you think about that, what are two numbers that multiply to negative 20 and add to negative 9? So we could have 4 and 5. You're probably thinking about 4 and 5 right off the bat, except they have to have opposite signs, okay? So that doesn't work. So what else do we have? 2 and 10? Do those add up to negative 9? Well, that doesn't work. 1 and 20. That doesn't work. Anything else go into 20? Well, I think that's it. So none of those numbers added up to negative 9. And so this is actually not going to be solvable by the factoring method, okay? That does not mean it's not solvable, okay? So, oops, factoring does not work for this example, okay? So this isn't going to happen often for now, but if you have something that looks like a tricky trinomial, but you set it up and it doesn't actually work out as a tricky trinomial, then that method isn't going to work. And so don't worry, because there's still 2 more methods for you to learn in this unit. One of those 2 methods will work for this problem. Let's do one last one. So take a look at this one and let's see if this one is factorable. So it's equal to 0. And is this factorable? And hopefully you're thinking back to the unit going, oh, she always told us GCF first. And this has a GCF of 3x. So we're going to go ahead and put our GCF of 3x. And remember, this is the setup, 3x times, and then you should have a polynomial here. 3x squared divided by 3x is x. And 9x divided by 3x is 3. So that's a minus sign there. So minus 3 equals 0. Now, when I go to do my t-chart for this one, it's a little bit different than all the other ones I've done because I don't have 2 sets of parentheses, but the factors are split up right here. So I'm going to put a line here to split up the factors. And this one is a little bit different again because I have 3x equals 0. Okay, but you can solve that. You can divide both sides by 3 to get x equals 0. And over here you have x minus 3 equals 0. And you can add 3 on both sides to get x equals 3. And so your 2 solutions for this one are 0 and 3. Okay, again, you can plug those back in to see if they work. And spoiler alert, I'm going to show you a way in class to solve this on your calculator so that you'd be able to check your answer. All right, so I hope this video was helpful. Don't you worry your pretty little hearts because there's lots more to come in class, and I will see you soon.